All right, so back to our plane mirrors. So they obey the law of reflection. And think about the image you see of yourself in a bathroom mirror every morning. What are its characteristics? Oh, and maybe I should say, remember, if one goes in straight in, it comes straight back out. Because if it goes straight in, its angle of incidence is 0, and so its angle reflection has to be 0, because it's measured with the perpendicular, with the normal. I think we ran out of time before I got to say that on the last one. And one other factor, you always need two rays to locate an image, because it's where the reflected rays intersect. So if you don't have two rays, it's pretty hard to find the point of intersection. We say you need at least two rays. You can use 18 if you want, but if you at least have two, you can find out where they cross. If you have 18, they should still all cross in the same spot. All right, so what are the characteristics of images formed by a plane mirror? Well, think of you in the mirror. What do you see? Well, first, we've already established it's virtual, because there's nowhere we can put a screen back here. And because these rays are not really reflecting, they're not really intersecting, they're only appearing to. So they're virtual. Hopefully you notice that it's erect, right side up. And that we're talking vertically right here, vertically erect. What else? Well, despite my diagram, they're always the same distance behind the mirror as the object is in front. So same distance from mirror as object. 1, 2, 3. What else? Well, they should also be the same size. You never look bigger or smaller when you're looking at yourself in the mirror. That is actually your size. And the fifth one, what happens when you wave with your right hand? The image in the mirror waves back with its left. So we say that they are reversed right to left. So whatever you see as your right hand is really your left hand. And that's when it gets tricky. Like if you're trying to do something in the mirror, like you ever tie a bow in the mirror and it's always opposite ways? Or if you're like reaching to fix something and if you're doing it based on the mirror, it's always the opposite way. So it's reversed right to left. So these are the characteristics of an image in a plane mirror. And there's some questions in your textbook connected to them. So on page 387, reviewing concepts, questions 1 and 4 to 7. And on page 388, and these are the problems, questions 1 to 3. And they're pretty straightforward, simple, easy peasy. Okay? But let's get to the fun ones, because the fun ones are images. So this was images formed by plane mirrors, number 1. The fun ones are images formed by spherical mirrors. Spherical mirrors, or more simply, curved mirrors. These are the ones that can cause real mind games. They're used in like fun houses and in places when they want to do optical illusions on you. Okay, so a spherical mirror is simply a mirror whose center either curves in or bulges out. Okay, so its reflecting surface is a portion of a sphere. It's not all in one plane. Okay, and there are 2 different types of spherical mirrors. Type 1 is called concave mirrors. In concave mirrors, the reflecting surface curves inward from the edges. So it looks like this, and this side is the reflecting surface. So this is concave. It caves in. The second type is called convex. And for a convex mirror, the reflecting surface curves outward from the edges. So this part is the reflecting surface of a convex mirror. Now, some of you would have these maybe in your homes, maybe in the bathroom. They're often used to magnify, like if they, maybe someone's plucking their eyebrows or wanting to look at their freckle or something and they need an image bigger, or for those of us who are old, we just can't see as well anymore. So we would use a curved mirror, because if we use it the right way, it can magnify the image. So we have concave mirrors and convex mirrors. Okay? Now, usually when we draw them, we draw a line straight through the center. You got to imagine that straight through the center there. My paper's tilted. And this line that goes straight through the center is called the principal axis. The principal axis. And because it's a curved mirror or a spherical mirror, there is a spot which would really be the center if it was a circle. The spot on the principal axis, which we label as C. And that spot, I need a new piece of paper. So that means I need to redraw it. So this spot, I know it's not as curved now. This spot, which is called C, is known as the center of curvature. So is this one. Okay, and the distance from the center of curvature to the mirror itself, this is going to surprise you, it's a capital R. And the capital R stands for the radius of curvature. And it's true over here too. So this is R, this is C. Okay, and this, remember, we call it the principal axis. Now there is a point halfway between the center of curvature and the principal axis that we call capital F. And capital F is known as the focal point. And the distance from the focal point to the mirror is little f, the focal length. Okay? We're going to start with concave mirrors. And for the next video, which will be day 3 of our absence, you're going to want 3 different colors. Okay? But first, I can always draw it better if I do the mirror first and then do the center line. So here's my C. Here's my F. And for a concave mirror, one of the things that we can always find the F, because lines that go in parallel to the principal axis, the was because it wasn't parallel. Lines that go in parallel to the principal axis get reflected in such a way that they pass through F. Okay? And so this concave mirrors are called converging mirrors for this very reason. Because lines that are going in parallel to the principal axis converge at a point F. And like I said, F, 2F is equal to R. 2 times the focal length is equal to the radius of curvature. Okay? Now there are 3 rays that we can use to locate images in a concave mirror. One of them is a ray going in parallel to the principal axis will always come out through F. Another one is just the opposite. A ray going in